Hi, welcome to Education with Eleanor. I'm Eleanor, that's me. Click subscribe and hit the notification bell for more videos on physics, mathematics and science. If you like this video, hit the thumbs up button.
We're going to learn about momentum and impulse. Before we even get to that, we need to understand some equations. So, the net force is given by mass times the acceleration. This is also the same as mass times the change in velocity divided by the change in time. So the change in velocity divided by the change in time, that's the same as acceleration. Let's keep going. If we were to look at just the numerator, that mass times velocity is also the same as the change in momentum. Okay, and that's divided by the change in time. The change in momentum, that top numerator, is also the impulse. It gives the impulse, and your denominator is still the change in time. So these are your equivalent equations that we need to work with. Okay, the velocity divided by time, that's your acceleration, so that we just understand what's going on there. Okay, so there, in terms of the equivalent equations, that's what's going on. So how do we understand this? The rate of change of momentum is directly proportional to the magnitude of the net force, and it's in the same direction. So what are we talking about here? Let's have a look. So when I say the rate of change of momentum, this bit is the rate of change of momentum. The change of momentum divided by the change in time. As soon as you divide something by time, you're doing a rate of change by time. Okay? So the rate of change of the momentum is directly proportional to the net force, and it'll be in the same direction. So that's just something you really need to know. The bit that we care about for today, I'll write this down, okay, what we need to do today is understand which of the equations do we care about. Now, we're being asked to find the magnitude of the force, we're given impulse, okay, and we're given time. So let's write this information down. The impulse, or change in momentum, is given by 20 Newton seconds. Now, if you're given Newton seconds, that's usually impulse. If you're given it in kilograms meters per second, okay, that's usually momentum. The Newton seconds is more indicative of your impulse, but they are the same units. They are interchangeable. It's not always clear to me, I'll be honest, about when Newton seconds and kilograms meters per second. But what you do need to understand is that usually, from what I've been told in the past, impulse is Newton seconds, and then momentum is kilograms meters per second. Sometimes they get interchanged, but I just needed to tell you about that, or where they come from. They are equivalent units, okay? And the reason for that is, if you have Newton seconds, newtons is given by kilograms meters per second, and then you've still got the seconds, okay? Oh, squared, sorry, newtons per second squared. And then you've got the seconds, which is to the power 1. So then you'll have kilograms and meters, and then the seconds, -1, add 1, just becomes seconds to the -1. And that's where your momentum units are coming from, okay? So that's where our dimension analysis or unit analysis for that is happening. Now, let's get back to what are we calculating. Oops. Let's write down our data. So we've been told the impulse, and it happens over 0.01 seconds. So that's time, 0.01 seconds. Okay, and we're being asked to calculate the force. Now, if we think about this, so we've got force, we've got time and impulse. So force is equal to the the impulse divided by the change in time, or time. So then our impulse was 20 Newton seconds. We divide it by the time period, so 0.01 seconds. Our seconds will cancel out. And this answer will be 2,000 newtons. In terms of the, direction, we don't need to worry about it, because in this question, we're being asked for the magnitude, okay? If you are being asked about the direction of impulse, then your direction will be in the same direction as the change in momentum. So you must calculate the change in momentum and find out the direction from the change in momentum, not just from momentum, okay? All right, in this question we're going to cover momentum and impulse as well. So when we read a question, you need to be able to read it and get to the information you really care about quickly, okay? The first sentence I put in for fun. You don't actually need it. It's the second sentence you need. So, Grumpy Cat hit the wall at a velocity of 5 meters per second and took 0.01 seconds to come to rest. And Grumpy Cat is a whopping 7 kilograms. We want to know what is the impulse of Grumpy Cat. Yeah? So that I've skipped the first bit of the first sentence, because when you're reading through questions, you need to be able to do some speed reading and figure out where's the actual data you care about. Okay? It is funny that Grumpy Cat saw a cucumber and got spooked. It's actually really not nice to do that to cats. I found out later. But yeah, okay? Let's write some information down actually before we even do this. So, Grumpy Cat hit a wall. Gently. He didn't hurt himself. So, initially, Grumpy Cat is heading towards the wall, and he'll have an initial velocity and a final velocity. So, initially, he's hitting the wall or approaching the wall at 5 meters per second. And then Grumpy Cat, okay, comes to rest at the wall. So Grumpy Cat's final velocity is going to be 0 meters per second. Okay? Now, for future reference, you need to think about this, because let's say to the right is positive. The reason being is sometimes if an object rebounds off the wall, their final velocity will be negative because it's in the opposite direction to which they approached the wall initially, yeah? So let's keep going. And then we know that the mass of Grumpy Cat is 7 kilograms, and the time at which this all happened was 0.01 seconds. Okay, we're being asked what is the impulse. So right now, in terms of, if we look at our equations, we've got the change in time, okay, but we don't have the impulse, and we don't have a couple other things. Let me have a look. But we don't have the force either, okay? What we can do is something a bit different. We know that impulse is a change in momentum, and we'll do that first, okay? So, impulse is the change in momentum. Now, it's always, I'll write this, final momentum. It's always a final take away initial. If it's a change in momentum, final momentum take away initial momentum. and that'll be m times v, which is your final velocity, take away m times u, your initial velocity. Okay, now on the left hand side here, I've done some factorise. You can factorise if you want to, you don't have to. So v take u. Now that's what that next step is. So the mass of Grumpy Cat was 7 kilograms and the final velocity was 0. We take away the initial velocity of 5 meters per second. So 7 times negative 5, 7 kilograms times negative 5 meters per second gives you negative 35 kilograms meters per second. Now, that's your change in momentum. Okay, if it was impulse, your impulse is negative 35 newtons seconds. Yep, I think. Wait a moment, do we want impulse? Yeah, so we want the impulse. So that's what your impulse is. Okay, and that's how we get there.
Thanks for watching, and this has been Education with Eleanor. Here are some more videos that you might like to watch. Remember to subscribe to have more videos on physics, mathematics and science. Hit the like button, the thumbs up button if you liked this video, and remember, physics is a story, and subscribe!